Okay, so just continuing on to the page to save trees, I did my other one, Dccr.01, which is about capacitors. And so I did a problem under, let's see, I did problem 16 in section 26.2. And so you have two capacitor plates having the area of 0.0100 meters squared, and initially they're separated by 1 millimeter, and they hold a charge of 3.30 microcoulombs, and it was positive. And so then it says how much energy is required to increase the plate separation to 2.00 millimeters. And so I did the relationship of the capacitor, which is E naught times area divided by D. And then energy is U equals Q squared divided by 2 capacitance. And so you can plug C in and you get this, which then simplifies to Q squared times D over 2 E naught times area. So then it's asking how much area is required, which means we need to look for change in delta U. So from 1 meter, which was the original, as I underline the important things. So goodness, it's not hopefully you can see it and it's not blurry. So we have 1 meter to 2 meters because it wants to know to increase the plate separation to 2 meters. So that means we're going from the original 1 millimeter to 2 millimeters as the final. And so what we can do is we can just plug in that difference, that change, that delta U into D here. So we have D final minus D initial. So we're going to do Q squared, which is given up here to be 3.3 microcoulombs. So that means we have to make it 10 to the negative 6 coulombs to get rid of the micro, and then 2, and then E naught, which is just a known thing. And then we're going to do 2 10 times 10 to the negative 3 minus 1 times 10 to the negative 3 meters, as we need to change from millimeters to meters. And so I have yet to have calculated that, but give me a second and I will. 2 times 8.85 times 10 to the negative 12. And then we're gonna because it's 2 minus 1, it's just 1. I think I did. Oh, I forgot area. I was like, I feel like I did something wrong here. Area. So area, it needs to be multiplied as well. So we need to do 0.0100 meters squared here. Goodness. So I was like, that number looks funny. So let me redo that. Oh boy. Give me a second here. Whoops. 0.01. 3.3 times 10 to the negative 6. Oh. Goodness gracious. I'm making mistakes left and right here. That should be squared. So I'm going to square that. Okay, so we get 0.01. Make sure I have my calculations right here. 2 times 8.85 times 10 to the negative 12. 3.3. Okay. So I'm getting that it equals 6.15 times 10 to the negative 2 joules. I'm going to check that. So I'm going to pause the video and just make sure that I have it correct. Okay, I'm back. I checked it and it is correct. So, oh, I know what I see. Okay. So let's just go over it again because obviously I didn't know what I was talking about. So 3.3 times 10 to the negative 6 squared, which is q squared. And then divided by 2 e naught times area. And then times, it's going to be 1 times 10 to the negative 3 meters. Times 10 to the negative 3 meters. Will come from that. So I ended up getting 6.15 times 10 to the negative 2 joules as the change. So that's how much energy is required to increase the plate separation to 2 millimeters.